Okay, from chapter 9, number 7, we have this ammonia molecule has 3 hydrogens, 1 nitrogen, and the if you were start over. If you look at the base of this molecule where there's a hydrogen here, and hydrogen here, this is an equilateral triangle. Right, it's an equilateral triangle, and the center of that triangle is, let's see, 9.4 times 10 to the minus 11th, or just a little under an angstrom away from each hydrogen, right? That's that distance. You got to remember, in an equilateral triangle, these angles, right? Each of those angles are 60 degrees. Okay, so we have to choose a coordinate system, and the book drew it so that one of these hydrogens lies along the x-axis. Let me look at the figure again real quick. I think the implication is in the figure that all of the hydrogens are lying in the xy plane. Yep, all hydrogens are lying in the xy plane. Okay. So how do we figure out where the center of mass is? All right, to do that, what we're going to do is we're going to go to equation 9-4. All right, so the center of mass in the x-plane is 1 over the total mass. All right, and then we're going to sum from I equals 1, I equals 1 to, how many masses do we have here? We have 4 masses, right? We have 4 masses, mass of each times its x position. All right, so in the x direction, we're looking at the total mass of the molecule, all right, times the sum of the weighted masses, or the weighted positions of each position, of each atom in the molecule. And we do exactly the same thing in the y direction. All right, the y center of mass, all we do is change these to y. Right, that's y, and this is y sub I. So the key issue then is figuring out what are all the x sub i's, right? So one of them is easy. The nitrogen is at 0. We'll call nitrogen 1. And then one of the, let me just put nitrogen. Okay. One of the hydrogens is at 9.4 times 10 to the minus 11 meters in the diagram, right? That's its x position. Now, what's the x position of the other two? Well, the origin is there, right? Let's say here's the origin. I always hate it when that happens. Let me get out of draw mode and get back in. So here's the origin. If we were to draw this like this, okay, so we've got 360 degrees all the way around, correct? That means this angle from here to here is 120 degrees. And that makes this angle from there to the axis 60 degrees. So if we wanted the x position of this, well, it's out a distance 9.4 times 10 to the minus 11th meters, 60 degrees from the negative x-axis. And the same is true for the other hydrogen. It is also 60 degrees from the negative x-axis, but below instead of above. Right? So in x, right? In x, the center of mass, in x, the position of these, right? Position of these is going to be this length minus the cosine of 60 degrees, or times minus the cosine of 60 degrees, right? So the minus 9.4 times 10 to the minus 11th meters times the cosine of 60 degrees. And then let's go ahead and get what that is. Goes 9.4 e minus 11 times cosine of radians of 60 degrees. 4.7 times 10 to the minus 11. It's 4.7 10 to the minus 11 meters. And the same is true for the last hydrogen. All right, so we have a hydrogen here and one each there. The nitrogen is at the center of mass. Nitrogen is at x equal to 0 in the diagram. All right, I'm going to take a quick look at that again, but I believe the nitrogen is sitting right on the y-axis at x equal to 0. Okay, now the mass ratio between nitrogen and hydrogen is 13.9. That's in the problem right there. Okay, so that means that our total mass is 13.9 times hydrogen, right, plus 3 times the mass of the hydrogen. So our total mass is going to be 16.9 hydrogen masses, right? Because the nitrogen mass is 13.9 times the hydrogen mass. So 13.9, which is the nitrogen plus 3 of the hydrogens, gives us 16.9 hydrogen masses is our total mass. And then we put together X center of mass. Well, we've got 1 over 16.9 hydrogen masses. Right, times, okay. So the nitrogen is at x equal to 0. So it doesn't even play into this. So 0 times 13.9 hydrogen masses plus 9.40 times 10 to the minus 11th, right? And I'm going to just go ahead and factor out. You can see already the hydrogen mass is going to factor out everywhere. So I'm just going to go ahead and make my life a little easier. Go ahead and take it out. All right, so 9.4 times 10 to the minus 11th, all right, minus 2 times 4.70, right, because these are both at the same location. That's meters, and that's meters, and the units on that don't matter, right? So we get the X center of mass is 0 times 13.9 plus 1 hydrogen mass times 9.4 plus minus 2 hydrogen masses times 4.7. Well, 9.4 minus 2 times 4.7 is just 0. And so what we've gotten here is that the center of mass along the x-axis is 0. Okay, now we have to work out what is the same thing in y. Well, in y, the only issue is where is the nitrogen, and why do I say that? Well, I say that because the nitrogen is the only one not at y equals 0. All right, so if we start looking at y center of mass, all right, so we've still got this 1 over 16.9. And we need to know where the nitrogen is. All the hydrogens are in the y=0 plane, so they don't enter into the equation at this point because they've got y=0 times their mass. So we're looking at the mass of the hydrogen times its y position. I mean, y of the nitrogen, sorry, right? Just 13.9 times the y of the nitrogen. So where's the nitrogen? Well, if you look in the y plane, what do they tell us? They tell us, one, we still got this 9.4 angstroms. That's what was coming out of my mouth there. Times 10 to the minus 11th meters, right? And we also have this, that distance L they give us is 10.14, which is nitrogen hydrogen distance. So 10.14, just a little over an angstrom, 10 to the minus 11 meters, right? So, and since we have a triangle here, we just need to find that side. So this squared equals hypotenuse squared minus the other side squared. All right, so y nitrogen equals hypotenuse squared. Hypotenuse 10.11 times 10 to the minus 11th meters, and all of that squared plus 9.40 times 10 to the minus 11 meters squared, and that's squared, right? So the distance, the vertical distance, is the hypotenuse squared minus, right, the other side squared. So let's just go ahead and get that. Equals 10.11. I'm going to take out the 10 to the minus 11. I'm going to take out the 10 to the minus 11 because it's a common factor. 10.11 squared minus 9.4 squared, 13.85. Let me get that straight. 13.85 equals 13.85. Okay, and that would be times 10 to the minus 22 meters squared. Okay, and so let's get the square root of 13.85, and we get 3.72. Make sure I got okay. Right, 3.72. times 10 to the minus 11 meters. Okay, so now we're back to our y center of mass equation. We have y center of mass is 1 over 16.9 onto 13.9 times 3.72 times 10 to the minus 11 meters. So equals 13.9 divided by 16.9 times the height. So 3 times 10 to the 3.06 times 10 to the minus 11 meters is where the y center of mass is, which is most of the way towards the nitrogen, right? Much closer to the nitrogen than the hydrogens, which makes complete sense since the nitrogen weighs much more than the hydrogens. Even all three hydrogens combined are only, they're less than a fourth of the nitrogen mass. All right, that's it for problem 7.